Welcome to our deep dive into the world of enterprise AI, where innovation meets the real world impact. We are going to learn how to take RAG systems from concepts to productions in just 3 steps on AWS. By the end of this, you will know exactly how to turn your ideas into a real working solutions. One key takeaway to get the best out of this video: whatever the stage of the journey you are in, pause the video and try to repeat those steps by yourself. It's all about getting the hands-on experience. So don't be afraid getting your hands dirty and really dig into the process. Let's get started. This is a well-known fact. If you want to create a smarter enterprise LLM applications, you need to utilize RAGs. RAG combines the power of information retrieval with generative models, allowing the applications to produce highly accurate and relevant responses. But how do you even start with RAGs? Well, we are going to talk all about that. Today, I will share 3 steps for building RAGs on AWS. In fact, there is a 4th one, which is I'm going to cover towards the end, so stay tuned. We will cover everything from conceptualizations to practical implementations so that you will get the best input for building RAGs on AWS. By the way, in this video, we choose to build on AWS. So let us start with the basics of RAGs. Okay, what is RAG? It is a technique that enhances AI models by retrieving relevant data from a knowledge base before generating a response. To put it simply, imagine you are sitting in a library and you have a problem. You can solve that problem with every knowledge you have in the library, but if you can get the right book for it, the answer would be very clear and precise. RAG is like your librarian who knows exactly where to find the right book to help you with a problem. So when you ask AI a question, it uses RAG to find all the relevant information first. Then it uses its logic to think about the information and give you a really good answer. Not just that, RAG is used to enhance the accuracy of the output, customize your responses based on specific data, and even extract a piece of information from a large pile of documents. These are a few niche use cases of RAG. Let's break down how you can take a RAG system from an idea to a full-scale, production-ready solutions. Step 1. Start by testing solutions on a single document. Your goal here is to make sure the responses are good enough. Think of this as trying out a new recipe on a small scale before trying it out on a big crowd. Here we can use Amazon Bedrock knowledge-based services to try out our ideas. Step 2. Now is the time to build a proof of concept or POC using tools like LanceDB and S3. This is where you put your system in front of real test users. It's like inviting a few friends over to test your recipe. Their feedback will help you to see if your idea can work on larger scale. If it does, great, you are one step closer. Step 3. Once your test users are happy, it's time to go big. Move your solutions to production using AWS powerful tools like OpenSearch, Amazon Aurora, or MongoDB Atlas for vector source. This is like taking your recipe to a restaurant kitchen where you can serve many customers reliably and efficiently. By following these 3 steps, you will be able to take your RAG system from simple tests to a fully operational solutions that is ready for the real world. We'll be going into further details about how those individual steps look like and why we choose them, what are the benefits, what are the value propositions for your business or a use case. Let's see how we can use Amazon Bedrock knowledge base. The first thing, we would like to go to the console.amazon.com and you need to log into the systems. You need to have an account to perform these steps. So once you log in, you will be able to go here. If you're service is not displayed because I recently used that. That's why it's displayed. If not, you can search for Bedrock, and here you go. You are in the Bedrock services, right? You can go into this hamburger menu, click on that. There are a bunch of options available. The things that we are currently interested is the builder tools, and within the builder tools we have a knowledge bases, right? So this is where you can build your knowledge base. You can have a document, you can chunk it, store into a vector store. So this is an abstractions over all those processes for the end user, so that you can quickly build and upload various kind of documents, try different chunking strategies, different databases, different vector databases that's available. However, we are not interested in this. What we are interested in, the step one, is chat with your documents. Okay, cool. So before you chat with your documents, you need to make sure that you have an access to the right models that you want to leverage or you want to utilize. So you can go on the left panel, on this left blade, you're gonna see in the last Bedrock configurations, there is an option called model access. So let's go there and make sure that you choose right models for your applications. Okay, so make sure that you choose the correct regions where you are planning to access your services. And remember, not all the models are available in every regions. Like for example, the Llama 3.1 405B is not available here in US East. So if you go here, you won't find it. But like if you change your regions to the Oregon, then you're gonna see that. So that's the things. However, there is an interesting fact that I will share with you. Even though I made a model selections, most of the models I have selected and that they are available to me for use. If your systems, like you are just starting up and if you don't have any models, when you request, it takes 1 or 2 minutes to get approval from the Amazon's, and it's auto approval. So just it's a policy documents that you are agreeing with. Make sure that you do that. Once you have an access, you can go to the builder tools, knowledge bases, go right to the chat with your documents. And in the chat with your documents, you go to your model. In the model, you're gonna choose you can go to the categories of the model providers here, but you will be surprised that there is only one model provider, which is Anthropic, is available. And within the Anthropic, even though I have an access to multiple models, only the Claude 3 Sonnet is available. So that's the interesting things I wanted to share with you. There are a bunch of models available, but like to chat with a document, this is the only model that you can use for your experiment. So let's choose that. Next thing is the inference parameters. I always like to keep temperature 0 because in the enterprise scenarios, I do not want the model to get creative, but like give me the right answer which it has been trained on. Okay, so that's the thing. Temperature is 0, top 5 is just 1. I think that should be sufficient. Length I'm not changing, is 2K is enough for me. There is a chat prompts. A template has already been provided by Amazon Bedrock for you. You can just leverage, you don't need to change anything. Now it comes the interesting part where the data, chatting with your documents, if you remember. So either you can choose your computer, means you can upload a document from your computer into the this particular the chat with your documents, or you can use an S3, upload your document into the S3 and refer that S3 here. Okay, so there are two options available. The guardrails we are not worried about, so we're not going to discuss in this video. So moving forward, I'm going to use a documents or a data sets which I have downloaded from Hugging Face. So this is the particular use case I would like to experiment with, because there are many insurance companies, they have a lot of questions, like the users have a lot of questions to the insurance companies. They want to get a lot of information about, but the resources are limited. How we can build a chatbot or a RAG systems that can help people to get faster answers using the LLMs, right? So I have planned to use the insurance QA question answers. As you can see, it's a model dataset card, a bunch of informations here. You can just go and refer. The interesting part I want to highlight is it has two columns. The first column is the questions. So as you can see, a question has been written, and the second column is an output, the result or answers to that question. So this is what we are planning to use for our scenarios, chatting with our documents. Okay, now remember, these particular data sets has more than 21,000 rows, which we may not need all of them. So what I have here done, I have used only the first 100 questions to chat with. Okay, so that's just keep in mind, we are not feeding the whole document. You can go ahead and you can do that, but like just for a test, just to demonstrate whether the system is working, so that we are choosing only the 100 questions that are highlighted in this particular document. The interesting part is like this. Remember, this documents currently is available in JSON-L format, and this means your systems, like now when we download this JSON, we cannot directly use JSON-L document because Amazon Bedrock knowledge base supports only limited amount of document extensions. So maybe I can highlight those document extensions to you. All right. A bunch of document extensions are like PDF, Markdown, text, doc, docx, HTML, CSV, XLS, and XLSX. Okay, so these are the only documents currently supported to upload. So what I have done, I took the data sets, took the first 100 question answers, converted into the CSV format, and I have selected them. And if you want to see that document, how it looks like, here you can see it. It's a simple comma separated records, question and answer. Now here we are. We have everything set up. As we mentioned in step 1, we don't want to have a lot of overhead building the systems, but just we want to experiment. But can we quickly test with our documents and see whether it's able to answer the questions that we are looking for. All right, let's go and ask the question. Oh, let me select the model. Seems I missed that. So now it's selected. It allows me to chat with that document right away in this window itself. So let me focus on what we're gonna ask. Let's go back to our data sets, and there are 2 records currently we have. So I'm gonna ask these questions. So let's go here and asking that question. Now that particular question has 2 different answers, right? But remember, we have selected top one, so it's gonna give you it's gonna pick up the top one only. All right, let's go and ask, and it started processing. So now what's happening behind the scene, the Amazon Bedrock is chunking your documents, preparing the vectors, and making sure it's able to find the answers. So here we go. It has got the answer. It says that it varies, however, usually it's around 30 days. And if we go back to the data sets, we're gonna see here within 30 days. This is what we have here in our data sets. So that's great, it's working. Now it worked here, but how do you find out that that's coming from that particular document? Okay, so here is the things, like you can refer, you can click on this. That's the first reference that we are getting to our documents, and in that document there is a first chunk.
So this is the whole chunk we are referring, and that particular whole chunk is mentioned here in Ohio, blah blah blah, all the way up to here. And if you want to go further in details, you can go here, and it's showing up the whole chunk now. So you are sure you can refer back the answers that you are getting from your systems is referring back to your documents, and that's great. So that's a good part of it, that we are successfully able to demonstrate that we can ask the question to our document and get an answers from it, right? So that's great. Looks like we are ready for the step 2. Right, to conclude the step 1, we use Amazon's user-friendly interface to upload the document. Once the document is uploaded, Bedrock automatically indexes the document for you. After that, we were immediately able to engage with the uploaded documents using the Amazon's conversational AI. What's the value propositions we see here? Step 1 gives us speed. Get started within minutes. Ease of use. No need for complex setup or AI expertise. Immediate results. Start seeing the value of RAG systems without a significant upfront investments. Alright, once you are satisfied in the step 1, the responses are good, it's a time to build a proof of concepts or POC and put it in front of real test users. To build a POC, we are planning to use LanceDB for vector storage and retrieval, connecting to your documents in S3. Connect the solutions with the Amazon Bedrock to consume the foundation models. Start testing and get the feedback from the user. Share the POC with your internal and external real test users and get the feedback. And use the feedback to iterate and refine the solution. Here is the general architectures for a POC. We have 2 sections. The top sections is for the ingestions of the data, and the bottom sections is for retrieving the information from those documents. In the ingestion of the data, when a document is dropped into an S3 bucket, it triggers a Lambda. And that Lambda actually gets the document, invokes the Amazon Bedrock embeddings, creates the vectors using the LanceDB, and store those vectors back into the S3. Once your embeddings are created, you can build another retrieval applications. For example, here we have built a Flask applications that exposes a retrieval APIs that can be consumed by the web applications, and the user can ask the questions using those web applications. So essentially, when user asks the query gets first embedded using the Amazon Bedrock embedding models. Once those embeddings are received, they can be further used for retrieving the knowledge from the S3 where we have stored our vectors. So basically, we take the help of the LanceDB to make a vector similarity search, and once you receive a bunch of documents which are stored in the S3, you send those documents to the Bedrock foundational model, and that helps us to organize our response that we can send it over all the way to the user. The repo for the POC is available at these locations, and there are 2 different projects in this repo: the ingestion pipelines and the retrieval that helps to generate the response based on your vectors. You can read through all the descriptions, how you can deploy the solutions, what is an input data format looks like for the data that we are planning to ingest into the S3. And once you have that, you can use, basically we are using the SAM templates to deploy those Lambda applications using a Docker containers. So there you can see further details here, the variables that we are planning to use, and also a method to deploy your solutions. In the solutions, we have a run.sh file that's available that you can utilize to deploy your solutions, which takes your account, your AWS account number that you need to supply before you build or run these applications. So essentially, what it does, let me explain to you. Once you download or clone the solutions, you can go to your ingest pipelines. You can go into the run. There are a bunch of actions that are happening. We are creating a Lambda Docker files. So we are not deploying a Lambda as a package, but we are deploying Lambda as a Docker containers. And that's the reason we are creating an ECR registry. Once you have an ECR registry, you log into the ECR, you build your Lambda functions. One interesting problem that I found that I'm on Mac, and by default it uses ARM64, but by default the Docker container registry uses AMD64. So make sure that you choose a proper platform while building your applications. And you create a tags, build an image, tag an image, push that image, and once the image has been pushed, you can actually do a SAM build for the source code that's available here. Okay, it has all the requirements. It has all the dependencies described into this requirement files. Build your Docker image, and just to walk you through what that Lambda function is doing, which I already explained in the architectures, but let me walk you through at the source code level. So in the beginning, as soon as your Lambda is called, you make sure, and actually your Lambda gets triggered based on your S3 events or the S3 dropping of the files, and you read that file, store it locally, and you build a page content. So basically what we are doing here, we are creating index using this page content. As you can see, we have a page content which we are building using the questions and answers based on our data sets. So just to show you how our data sets looks like, and here is the data sets. The first portion is the questions, the first column is a question, and the second one is the response. And this is what essentially we are building, a page content that we are planning to store in the vector store. So you build that whole, you read every line, every item line by line from this file, and you created a content. We are not using any chunking strategy because we use every question answer as a one group of chunk, and we are ingesting into the LanceDB. Okay, and once you have that things available, you connect to the LanceDB, and I'm gonna show you what this means, where essentially the LanceDB, this is the place where LanceDB is planning to store all our vectors. Okay, you open the tables here, and then you, if the table is there, you'll be able to. If not, it's going to create a table for you, and then we're planning to store that information into that S3 buckets. Now you have an understanding about the source code and the architectures. Now let's plan to deploy these solutions using the command line. So we have already mentioned the prerequisites that you need AWS CLI, and you also need an AWS account, and the configure is AWS account on your CLI. So let's go to the applications, and basically once you clone the repo, go into the ingest pipeline folder, and once you are there, make sure that you have created an environment for this ingest pipeline. There is a requirement files there, so basically you can use and create an environment, and you can run the run.sh file, which I already explained to you here. That's located over here. So once you run the file, it's checking for repository, it exists, so it moves on, builds a Lambda function, creates a Docker container for it, push the Docker container to your ECR registry. Okay, in the last steps, what we are doing, we are using the SAM to deploy an infrastructures. So this is where we are using the SAM deploy, which internally uses the cloud formations to deploy your infrastructures. We gave the name LanceRag, the image, and some of the parameters that it needs. So once those information is configured, you run your run.sh, and while in the last step of the run.sh, it's trying to create a bunch of resources that you can read it here. The operation is add, and what kind of resources is creating. As I mentioned earlier, it creates the bucket, the functions, and role and the permissions for those Lambda functions that we have. And it goes into detail how the whole Lambda function is getting deployed. It goes into detail how the infrastructure is being deployed. It creates those infrastructures. At the end of the whole infrastructure deployment, you're gonna see the ARN that's to your Lambda functions, and the S3 bucket that we have. So just to correlate the information. So as you can see, we have a RAG LanceDB bucket has been created. In the last steps we mentioned that, and here we are. It's an empty right now. Go to the stack, and you can see here your CloudFormation stacks which has been deployed. If there are any errors or anything, you can see it here. Also, let's go back to the Lambda functions that has been deployed. So here, as you can see, the new Lambda function has been created. You can see we are using the Docker image, and there are a bunch of permissions that we did. You can refer here, and once you are comfortable with that, just want to show that whenever your Lambda function is running, it creates CloudWatch logs, which you can directly go here, and it's gonna show you. So let me delete this. So when you first time come here, if your Lambda function didn't run, then this would show you in the red notifications. But as soon as you run your Lambda functions, it will turn into the green, and it will create a new log streams here for your analysis. So that's about the CloudFormations template, Lambda creations, and the CloudWatch log creations. Now let me show you how we can run the whole solutions. So let's go to the RAG LanceDB. There is no file here. The Lambda hasn't run, as I just showed you. There is no streams, no records. So what I'm gonna do, I'm gonna pull one of the documents, the data1.json. If you remember, this is the record where we have 100 subset, or this is a document which has 100 records of question answers, which we created out of the huge data sets that we had here, just for your information. So what we are going to do, we just drop that file and try to upload it. As soon as we are uploading it, just to demonstrate, over here it's gonna trigger these Lambda functions. So let's go to the Lambda function. There is by this time the Lambda function has already deployed. Just refresh it. As you can see, a new stream record has been created. And remember, when you first time come here, if it is a very fresh deployment, it takes some time for this Lambda to be brought in and to warm this Lambda, and because of that you're gonna see a timeout. But do not worry about that. You can actually resume and wait for the lambda to actually, as you just saw, it will try to retry, and once the retry is successful, it will able to run your Docker container with the S3 event that we have received. So what is it in happening here? As you can see, we read the files. After reading the files, we created the embeddings, and we also created a doc table because it didn't exist before. As you can see, not found, creating one, and once that is done, it's gonna store that all the vectors into the S3. So now let's go to the S3. If you remember the objects, we just had data1.json that we uploaded. Let me refresh this. Now you're gonna see the embeddings. Where this is coming from is coming from here. If you remember, I showed you that the end of the whole process of the vectors being created, we store those vectors into the S3. And this is where we are opening our LanceDB. This is our bucket name, and this a path or a prefix that we are using. So it has created that prefix. You can go into this, get some details. If you are interested, you can look into that, download. This is the structures from LanceDB, and the data is stored here. All right, so now we completed the first sections of the ingestion pipeline. So this is all completed. Now let's do the second sections, which is the retrieval. Right now I haven't built an applications which is exposed to the using the browsers, but I'm gonna demonstrate the same thing using the call command. You can go ahead and build a front-end applications. I mean, it's super easy to create. The focus here is the components that are related to the racks, and how those components we can orchestrate in a way that helps you to build the whole ingestions and retrieval pipeline. So just be aware that the whole solution, like we are not building the apps here, but I'm gonna demonstrate using the CLI. Okay, let's go to the CLI. Now let me make a call. So in this call, right now what I have done, there are 100 records, and out of 100 records there is information about life insurance, and there is an information about the life insurance, and I just want to see what I can combine with it. Right, so I'm running the command, I'm running the call command on that records. As you can see, let me just explain what just happened. The user is making a query. Instead of browser, we are doing a call. You make a query. It uses this query to create embeddings and make a call to the vector stores. And from the vector stores, it received the data, a context, and which was passed to the Amazon Bedrock for further processing to create a response. And once that response is generated by those LLM foundational models, it gets passed to the users, and this is what we are seeing. Now remember, this is a detail, like I can show you up, you can look up by yourselves into the data sets wherever there is a life insurance is mentioned, and about the combined where it is mentioned, you can look up this information, and it clearly mentions that these are the two different ways where you can combine your life insurance. So there you go. You ask questions, it replies. You can try different questions, and maybe let me ask, can I combine life insurance with auto insurance? Right. So remember, if you go into the data sets, there is no such record which talks about this. However, here is what it finds. Based on solely on the given context, there is no information about the combining the life insurance with the auto insurance. This is what I was expecting. But it goes ahead and gives some more details about what it can do, right? So this is pretty cool. So here we are, a POC that we just created right now, and now you can use this POC and give it to your test users, see how it performs. Now let's do a quick rundown of the step 2. What are the value propositions here for us? Low cost to entry. Building a POC with minimal requirements here. We just took the documents, we saw it's working, we created a POC using a simple Lambda applications, create a simple front-end application. There are a bunch of frameworks available, including Streamlit. You can use it. The second thing is validate the approach before a full-scale deployment. You don't want to deploy in productions, you want to test it out. MVP, the minimal viable product, or simple solutions, a POC, a proof of concept, just to verify whether your system works. And at the end of the POC, like if you recognize there is a value your test users are getting, the system is responding well, you are getting the desired accuracy, then it's the time to scale your POC to a production grade deployment. So we'll talk further in the step 3.